posted some announcements in the chat box regarding the quiz. Uvle is now live, so you can now take your quiz. The quiz will be open until 12 noon of March 12. So you have approximately the next 3 days to do the quiz. And your problem set has been released this morning. It was released at 8 a.m. And you have until March 16, 5 p.m. The problem set should not take you too long to do. If you studied the material for week 1, you can actually solve those problems in maybe 10 minutes each if you study the material for week 1. No, if you're going to have to study while solving the problems, then that's a different question. So any questions with regard to any of the materials we've taken up so far?
Sir, meron po. Sir.
Wala bang mga tanong?
Sir.
Malinaw ba yung subject matter? Hindi malabo.
Hello, sir.
It's your chance to ask questions. No? There's no such thing as a stupid question. So now it's your chance to ask questions.
Hello, sir.
Mark, you want to recite your question so everyone can hear it?
Sir, can you hear me po?
Sandali hindi pala ako naka-earphone, sorry.
Hello, sir.
Yeah, okay. Thank you.
I have a question for last lecture.
Sige.
In slide 45 po.
Slide 45 ng... Ano yung...
week 1 po, last week po.
Anong slide, anong question mo in particular?
Yung example po, pag po ba yung KVL, pag po dalawang voltage source, same lang po yung KVL. Well, I mean, pag mag-KVL po, pero yung sa isang loop, yung other voltage source po, hindi mo na siya papansinin.
Teka, anong slide number to? Better if I pick up the slide.
Number 45 po. Example po siya ng circuit.
Slide 45?
Yes po. Example 6.
45 is example 7. 7?
Yung 6 po.
6?
Yes.
Slide 44.
Oh,
okay. Sige, let me share it, no? Para makita ng lahat ng tao.
Sir, pag hinanap po yung voltage ng R2.
Okay, this one? Okay.
Yes po, yan.
Okay. Anong tanong mo?
Pag po hahanapin yung VR2.
Itong VR2?
Pag mag-KVL po, di ba po, dun sa 36 volts na voltage source, then sa R2, then dun sa 4 volts.
So dito ka mag-KVL?
Opo.
Dito
wala pong effect yung isa pong voltage source sa right. Pag
hindi mo kailangan tignan yon. No?
Ignore na lang.
Kung dito ka mag-KVL, dito ka lang mag-KVL.
Okay po. So para i-ignore mo na lang po muna yung isang voltage source. Wala po siyang effect.
May effect yan, syempre. It will have an effect. In other words, all of the sources here, all of the sources in this circuit will affect all of the voltages in this circuit also. But when you're doing a KVL, you don't have to look at that. Hindi ibig sabihin na hindi ito makaka-apekto dito, no? Kasi gagaya nito, you don't know. Paano ba na-compute ito? Baka na-compute ito dahil may voltage source dito. So that was part of the computation of these 4 volts. So may effect siya. But then if you do a KVL here, ito lang yung titignan mo.
Okay po. Thank you po.
Gets mo yung
Gets
ibig
po.
sabihin?
Gets po. Okay po. Nakuha po. Thank you po.
Any other questions from anybody else? Yeah, there's another question from More Piatos. Can you ask your question, please? Hello? Anong nangyayari doon sa circuit sa dulo ng module 2 slides? Naloko na. I just okay. Balikan natin uli yan. Is this what you're talking about? Ito ba yung pinag-uusapan natin? Yung pinag-uusapan mo? What do you want to know about this? Maybe you can you can turn on your audio para marinig kita.
Sir, yung nag-iisang wire po.
Ito.
Paano po yung nag-work?
Nalilito ka sa nag-iisang wire?
Opo.
Actually, ano lang to eh. This is just your common reference eh. No? This is your common reference. In other words, all of the voltages in the circuit are with respect to the common reference. No? So kung tutuusin, itong current na to, I is equal to 0. No? wala kang current na dadaan dito sa, wala mo yata yung ano ko. Ito I is equal to 0. Wala kang current na dadaan dito. So for all intents and purposes, parang hiwalay itong kaliwa at saka kanan. Kasi wala ka namang current na dadaan dito eh, no? So hiwalay yung kaliwa at saka kanan. Pero pinagkabit sila kasi iisa lang yung reference ng mga voltahe mo. This is just a common reference. So wag kang malilito diyan.
Okay po, sir. Thank you po.
Okay. Sino ba may unanswered questions? You can just speak up, ano? Oh, okay. Mukhang wala na. Any other questions? Okay. So let's go back to okay, let's start the lecture for today. No? Okay, so ano ginawa natin last week? No? Last week, what did we do? We studied basic circuit quantities. So we studied charge. And then we said when charges move, nagkakaroon ka ng current. No? Current is the movement of charge. No? I is equal to dq dt. And then as charges move in an electric field, it can go from a point of higher potential to lower potential or vice versa. And the measure of difference in potential versus charge, we call that voltage. So pinag-aralan natin charge, pinag-aralan natin current, pinag-aralan natin voltage. And then voltage and current together results in power. Power is voltage times current. And power delivered over a certain period of time results in energy. Energy is equal to, if it's constant power, power multiplied by time. And then we took up resistance. Resistance is the tendency of an element to resist current flow. And then we took up Ohm's law. Ohm's law is V is equal to IR or I is equal to V over R. Tapos kinuha natin yung dalawang fundamental circuit laws, which is your Kirchhoff's current law and your Kirchhoff's voltage law. Okay. Kung tutuusin, kung alam mo yung KCL, alam mo yung KVL, dapat masosolve mo na, dapat kaya mo nang isolve halos lahat ng circuit problems. Kung tutuusin, no? Because when you have a circuit, all you have to do is form your KCL equations, form whatever KCL equations you can, form whatever KVL equations you can, and you should be able to hack out a solution to the problem. So yung problem set ninyo, for example, and then the examples that were given as part of module 1, those were all hacked out solutions using KCL and KVL. Now, starting itong week 2, we're going to try to be a little bit more structured in the way we solve circuit problems. So first, we're going to take up circuit analysis techniques. And then next week, you're going to take up a very structured method of solving circuit problems, and we call that nodal analysis. Okay, so anong kukunin natin for today? This is the summary of what I'm going to take up for today. First of all, I'm going to discuss the principle of equivalence. Then I'm going to go into circuit simplification. We're going to take up only 4 cases for circuit simplification: resistors in series, resistors in parallel, sources in series, and sources in parallel. Then we're going to take up voltage division and current division. Okay. So let's begin by a discussion of the principle of equivalence. To read, 2 electric circuits are said to be equivalent with respect to a pair of terminals if at these terminals identical currents flow when identical voltages are applied. Okay. Let's say these are 2 circuits, circuit 1 and circuit 2. and I have terminal A and B here, and I have terminal X and Y here. Okay, intuitively, ano ang ibig sabihin kung circuit 1 is equivalent to circuit 2, no? Ang ibig sabihin nun is if I have a third circuit, let's say I have circuit 3, okay, let's call this anyway, no, let's call this RS, no. Kung meron akong third circuit, hindi nito malalaman kung equivalent ang 1 at saka 2. Hindi nito malalaman kung sino ang nakakabit sa kanya, whether it is 1 or it is 2. So ito ikabit ko dito, or ito ikabit ko dyan. This circuit 3, will not be able to distinguish. Which is which? That is the meaning of equivalence. No? Hindi malalaman ng circuit 3, circuit 1 ba ang nakakabit sa akin or circuit 2? Because from the perspective of circuit 3, the two circuits feel exactly the same. Yun ang ibig sabihin ng equivalence. So putting it another way, no? Let's say I apply a voltage V1 to circuit 1 and I get a current I1. And I apply a voltage V2 to circuit 2 and I get a current I2. If the applied voltage V1 is equal to applied voltage V2, and I get the same current that flows in circuit 1 and circuit 2, that is I1 is equal to I2, then with respect to terminals AB and XY, circuit 1 and circuit 2 are equivalent. So that is, mathematically, that is the definition of equivalence. But intuitively, I already told you, intuitively, you cannot tell, no? A third circuit will not be able to tell, ano ba yung nakakabit sa akin? Is it circuit 1 or is it circuit 2? Okay, what is circuit simplification? No? Circuit simplification makes use of the principle of equivalence. This is performed when we're interested in just a few unknowns in a circuit. So hindi ganun kadami ang kailangan nating i-solve, no? Konti lang, just a few unknowns in a circuit. The technique is to transform a portion of the circuit into a simpler equivalent circuit while, and this is very important, while preserving the unknown quantities to be determined. I'm going to explain what we mean by that later on. And then the simpler circuit will make it easier to compute for the desired quantities. So in essence, I have a complex circuit. So this is the typical problem. The typical problem. Let's say I have a complex circuit. I want to compute for I. For I. So what I want to do is I replace this. Replace with a simpler equivalent circuit. So this is a complex circuit. I want to compute for this value of I. Yun lang yung kailangan ko i-compute, no? Itong value lang ng I. So papalitan ko to ng isang mas simpleng equivalent circuit. Replace it with a simpler equivalent circuit. And that will make it easier for me to compute for I. Okay, in doing circuit simplification, we have to recognize certain structures, certain resistance structures. No?
And the first is resistances in series. Siguro alam na niyo to, no? Some of you from your high school probably already took this up, no? If I have n resistances in series with respect to terminal A and B, you can replace that with a single equivalent resistance where the equivalent resistance is just the sum of the individual resistances. And it's very easy to prove this. Okay. Let's say I apply a voltage here, V, plus or minus V, and I get a current I. So this is the voltage VR1, this is the voltage VR2, this is the voltage VR3, all the way to VRN. If I apply KVL here, what am I going to get? No, I'm going to get V is equal to VR1 plus VR2 plus VR3 all the way to VRN. But VR1 is I times R1. VR2 is I times R2. All the way to VRN, which is I times Rn. No? Remember that this current I is the current that flows through this entire circuit. So V is equal to I times R1 plus R2 all the way to plus Rn. Now let's look at the circuit here on the right. No? If these are equivalent, that means if I apply this V, the same V, I'm going to get the same I. No? And V is just equal to I times R equivalent. So kung itong V na to at saka itong V na to pareho, kung itong I na to at saka itong I na to pareho, ibig sabihin ito dapat pareho dito. So that is this equation. A very simple proof of resistances in series. Now this is just a review because I discussed this already with you last time. No? When are two elements in series? Two elements are in series if they are connected together at one point, and at this point, nothing else is connected. Then these are in series. Okay. The minute something else is connected here, hindi na siya in series. Okay? So that's very important. I always see students that make that mistake, ano? They identify wrongly two elements that are in series, failing to see that something is connected at their point that they are interconnected. Hopefully none of you will make that mistake. Okay, the other simplification rule that we're going to study is when resistances are in parallel. So here on the left, I have n resistances in parallel. Parallel meaning to say they are connected at both their ends. Both their ends are connected. And I maintain that can be represented by just one equivalent resistance, where 1 over Req is 1 over R1 plus 1 over R2 plus 1 over R3 all the way to plus 1 over Rs of n. No? How can I prove this? So I'll use the same technique. No? If I connect a source here, V, okay, now let's assume that a current I will flow. That I, this particular current, will distribute to these different resistors. So I'm going to get I1 here, I2 here, I3 here, all the way to Is of n here. And according to Kirchhoff's current law, KCL, I is equal to I1 plus I2 plus I3 all the way to plus IN. Now notice, this voltage V is the voltage across all of these resistors. You only have one voltage across all of those resistors, and that is the voltage V. Therefore, what is I1? I1 is just V over R1. I2 is V over R2, all the way to IN, which is V over Rn. So I is actually V multiplied by 1 over R1 plus 1 over R2 plus 1 over R3, all the way to 1 over Rn. Now let's look at the right side. I apply V. I should get the same I. Now for the right side, what is I? I is equal to V over R equivalent. This I is the same as this I. No? This V is the same as this V, and therefore this must be equal to this. And that is what I'm saying here. So those are resistances in parallel. Special case, when you have two resistors in parallel, no? Two resistors in parallel. R1, R2. Okay. R equivalent is equal to R1, R2 over R1 plus R2. No, this is product over the sum. Product over the sum. Now we say R equivalent, that's looking into these two terminals. No? So if this is AB, this is another way of showing it. No? R equivalent is looking into terminals AB. Let me just erase this. No? Okay. R equivalent will always be less than R1 and R2. So itong R equivalent na to cannot be greater than either of these resistors. The equivalent resistance of any of resistors in parallel will always be smaller than the smallest resistance. Okay. If R1 is equal to R2, R equivalent is equal to 1/2 of R1. Example, if this is 5 ohms and this is also 5 ohms, what is R equivalent? That's just 1/2 or 2.5 ohms. Okay. I have a question for you, no? What is R equivalent? Anong value ng R equivalent? Can I see some answers in your chat, in the chat? Anyone? Okay, somebody says, so you're saying this is R1. Okay, somebody says R1. Any other answer? R1 then? Okay. Okay. Thank you for answering. No, I admire people that try to answer. Please try to answer if you can, because it's what stimulates your thought process. No. Okay. This is the short circuit is a resistor whose value is 0. A short circuit is a resistor whose value is 0. So knowing that, anong value ng R equivalent? Ngayon na sinabi ko yan. What is now the value of R equivalent? So dun sa sumagot kanina, okay, so now everybody sees that R equivalent is actually equal to 0. No? This will equal 0. In other words, no? Whenever I have a short circuit, then if I have this particular situation, then I might as well get rid of this. No? For all intents and purposes, whenever I have a short circuit, anything that is parallel to that short circuit can be removed from the circuit without changing the behavior of the circuit. Because the equivalent resistance anyway is equal to 0. Okay? So, pag may nakita kayong ganito, equivalently, short circuit lang yan, no? Between A and B. Kahit tanggalin na nyo yung R1. So that is a circuit simplification that you can do. When you see a resistor that's shorted out, you just take it out. Okay. When are two elements in parallel? No? So I discussed this last time. Two elements are in parallel means that they are connected at both ends. No? So this is parallel. Sometimes no, you'll see an element this way, see an element that way. Right away, sabihin nyo, uy, parallel siya. No? But all of a sudden, merong element din dito. Then this is not parallel. No? Because they have to be connected this end, and they also have to be connected this end. Dito kita nyo, they are not connected. No? So ito parallel, this is not parallel. Again, please don't make that mistake. No? Please don't wrongly identify two elements that are not in parallel to be in parallel. Okay, so let's take up an example. So this is again the typical problem. I'm only interested in V. So what I want to do is I want to simplify this. I want to simplify this to make it easier for me to calculate V. Where do I start? Usually, pag ganito, I'm trying to preserve these terminals. I will start at the farthest part. No? So I'll start dito. So what are these two in series? Anong value nitong dalawa in series? Anyone?
16, sir.
16, that's right. Ano? Okay. So here, if I redraw this here, that is just one resistor equivalent to 16. No? So I now have this 64. So anong value ngayon nitong dalawa in parallel? Okay, so use the formula product over sum. Anong value nitong dalawa in parallel? Okay, anyone? Di ba nyo dala yung mga calculators nyo? That's right, no? 12.8. So from Marthy, 12.8. So with respect to these terminals, this is equivalent to 12.8, no? So now this 12.8 is in series with 7.2. Okay. So with respect to here at this point, this is already what? 7.2 plus 12.8 is 20. And the 20 is in parallel with 30. So itong 20 at saka 30 in parallel, this comes out to 12. No? This comes out to 12 ohms. So finally, my equivalent circuit is just this. No? My equivalent circuit, if 5 amperes. This is A. This is B. With respect to AB, I only have one resistor that is equal to 12 ohms. So anong value ng V? So simple na lang yung pag-calculate natin ng V. No? We just use Ohm's law. You have 5 amperes flowing, 12 ohms, so V is 60 volts. 60 volts. So yun na yung sagot natin. Okay. Now remember what I said earlier, ano? You have to preserve these terminals when you do your equivalent circuit because this is your unknown. So let me twist the problem a bit. What if this was my unknown? Let's say V1. Can I use circuit simplification? Kung ito yung unknown ko. If this is my unknown, then I have to preserve these terminals. I have to preserve these terminals. So ang dapat na isi-simplify ko is this circuit with respect to these terminals. No? Right now, hindi pa natin magagawa yon because we have a source here. Later on, you're going to discover that there are techniques available for that. Pero right now, hindi pa. No? So remember that if I want to simplify, if I'm solving for B, I have to preserve these terminals. No? And so right now, we still don't have a way of simplifying if this is my unknown. Pero ito, it's very easy. No? Because what we simplify is a purely resistive circuit. Any questions with regard to that? Okay. Here's a circuit that will demonstrate what we mean by circuit topology. No? That a circuit can be redrawn in many different ways and yet be exactly the same circuit. So in this particular example, you have to recognize that a wire can be compressed into a single point and the point can be stretched into a wire. I mentioned that, I think, the last lecture. Let's see. Let's hear it from you. Okay, I want to know the equivalent circuit between A and B. Do you recognize any elements that are in series or in parallel? Anyone? Meron ba kayo nakikitang in series or in parallel? Okay, I got an answer from Mark. Walang in series or in parallel. Does everybody agree? Let's hear from the rest, no? Yung mga natatakot ba kayo? Commit to an answer. Don't be afraid of answering. So I hear from Marthy that may in parallel. No? Let me label the resistors. No, let me call this 1, 2, 3, 4, 5, 6, 7, 8. Who can tell me? Give me resistors that you think are in parallel. Just give me the numbers. What are in parallel? Sabihin sa akin yung mga numero. Anyone? What are in parallel? Or what are in series? Wala kayong nakikitang in parallel? No, somebody mentioned, no, na there are multiple resistors in parallel. Who's this? Danielle. Daniel, give me 2 resistors that are in parallel. Asan ba si Daniel? Biglang tumahimik. 2 and 6. Unfortunately not, no? 2 and 6. So sabi ni Daniel, these are in parallel. Okay, you satisfy one criteria, no? That they are connected together at this end. But if 2 and 6 are in parallel, dapat itong point na to at saka itong point na to magkakabit. Hindi sila magkakabit, ano? There's a resistor in between. So 2 and 6 are not in parallel. No? Remember, kailangan magkakabit sila at both their ends. So 2 and 6 are not in parallel. Well, let me ask you. 2 with 5 plus 6. Okay, good you mentioned that, ano? If you say 2 with 5 plus 6, you are saying that 5 and 6 are in series. Right? But remember what we said, no? For 2 elements to be in series, there should be nothing else connected at the point they are connected to each other. So 5 and 6 are connected here, and there's 8 and 7 that's also connected there. So 5 and 6 are not in series. Okay, let me ask you this. Is 1 and 2 in parallel? Is 1 and 2 in parallel? Okay, sabi ni Mark Gino, no. Test natin, ha? Test natin if 1 and 2 are in parallel. So this is 2, and this is 1. Are they connected at one end? No. Are they connected at this end? Yes, they are connected at this end. Are they connected at the other end? This is connected there. Yes, they are also connected at the other end. Therefore, 1 and 2 are in parallel. No? Remember our condition, they have to be connected at both ends. So they're both connected here, and they are also both connected here. So 1 and 2 are in parallel. No? Now, somebody mentioned, si Peter Sapalo said that 3 and 4 are in parallel. The answer is yes, they are in parallel. Right? 3 and 4, they're both connected here. Right? They're both connected there, 3 and 4. What about their other ends? The other end of 4 is connected to the other end of 3. So they are also both in parallel. Okay, so why am I going through this? You have to recognize elements that are in series and elements that are in parallel. Okay? Let's do this, no? Let's say this is A. This is A. Remember, I said, no? A is a point, you can stretch it to a wire. And let's say this is B. B is a point, you can stretch it to a wire. If this is A, this is also A, and this is also A. A din yan. If this is B, this is also B, and this is also B. What is between A and B? Ano yung nasa gitna ng A and B? Itong 1. That is between A and B. So you 4K. Itong 2. Is that between A and B? Yes. It's between A and B. So I have another 4K. Is 3 between A and B? Yes, it is also. Ito rin. It's between A and B. So I have another 4K. Finally, it's 4 between A and B. Yes, still another 4K. So notice 1, 2, 3, and 4 are all in parallel. They are all in parallel. Now, what about 5, 6, 7, and 8? I have another point here, point C. So let's say this is C. What is between A and C? Okay, who can tell me what two resistors are between A and C? Can I hear from you? 5 and 7, that's right, no? So between A and C, I have 5. This is 1K. And I also have 7. And what is between B and C? Between B and C, I have 6 and 8. So between B and C, I have 6, which is 1K. I also have 8, which is 1K. Okay, now having seen this, what is my resistance between A and B? So dapat madali na nyo mako-compute yan. Okay. What is now my resistance between A and B? Can I hear the answer? Okay. Medyo may konting ano, no? May konting lag. I have 4K resistors in parallel. What is 4 in parallel with 4? That's 2. Another 4 in parallel with 4 is another 2. 2 in parallel with 2 is 1. So actually this 4 in parallel is equivalent to 1K. Now remember I said that when you have equal resistors in parallel, 2 equal resistors in parallel, nangangalahati siya. So yung dalawang 4K in parallel, magiging 2K. Yung dalawang 4K in parallel, magiging 2K din. Yung dalawang 2K in parallel, magiging 1K. No? And then ito, okay, 1K in parallel with 1K is 0.5. 1K in parallel with 1K is 0.5. 0.5 in series with 0.5 is 1K din yan. So finally, I'm going to get 1K in parallel with 1K. And yes, the answer, which some of you already compute, is 0.5K. So this is the answer. Okay, don't forget the K, no? Hindi lang 1/2 K. Okay, so point is this: don't be intimidated by this drawing. No? Whenever you see the drawing, try to convert it to something like this. Identify what are all the single points. So notice that this point is just the same as this point, and this point is just the same as that point. And then you try to map out what elements are between what points. And then you're going to easily see now which are in parallel and which are in series. Okay? Okay, let's move on. The next are sources in series. And we'll start with voltage sources in series. If I have n voltage sources in series, then those n voltages in series can be represented by just one equivalent voltage whose value is the sum of all of the different voltages. No? And that's very easy to show using KVL. So let's say this is VAB, double subscript notation. If I apply KVL, VAB is equal to V1 plus V2. Sorry, there's an error here. No, that should be plus minus, plus minus, plus minus. V1 plus V2 plus V3 all the way to plus V sub n. No? Dito naman sa kanan, if this is VAB and I apply KVL here, I'm going to get VAB is equal to V equivalent. No? Since VAB is the same, then this should be equal to this. Now take note of the polarities. Okay, take note of the polarities. For example, give an example. If this is A and this is B. Let's say this is V1, this is V2, and this is V3. What is V equivalent? In this case, V equivalent is equal to V1, but it is minus V2, and it is minus V3. Okay, because this is opposite in polarity to this, and this is also opposite in polarity to this. So take note of the polarities. What about current sources in series? What about current sources in series? You can have current sources in series, no? Like this. No? So these are n current sources in series. But for the circuit to be valid, all of those sources have to be equal. No? All of those sources have to be equal. Hindi pwedeng hindi siya equal. Kasi, for example dito, pag nag-KCL ako dito, I'm going to get I1 is equal to I2. So if this source is not equal to this source, then that is an invalid circuit. Right? And so what is the equivalent current source? The equivalent current source is just one of the current sources, that is I1. Otherwise, the circuit is invalid. Okay. Now, what about sources in parallel? Ganun din, no? Sources in parallel. Here I have n voltage sources in parallel. For this circuit to be valid, V1 must be equal to V2, must be equal to V3, must be equal to V of n. No? And my equivalent voltage source is just the value of any one of the voltage sources. Otherwise, if this is not true, I have an invalid circuit. I think I pointed this out already. I might have pointed this out already in last week. I gave you an example. I think, no? What if I have two batteries? Yung isang battery ko 12 volts, yung isang battery ko 6 volts. So what is the value of VAB? Let's say this is A and this is B. If this is 12 volts and this is 6 volts. If I apply KVL here, dito sa loop na to, I'm going to get VAB is equal to 12 volts. But if I apply KVL dito sa bigger loop, I'm going to get VAB is equal to 6 volts. So notice that this is inconsistent. And therefore, this is invalid. Right? That is an invalid circuit. In other words, you cannot have ideal voltage sources in parallel because the result will not satisfy Kirchhoff's voltage law. Now, when you have current sources in parallel, dito naman, current sources in parallel, then by virtue of KCL, the equivalent current source is just the sum of the different current sources. But again, you have to take note of the direction. For example, if I have AB Let's say I have I1, and then I have I2. Okay. Let's say this is I equivalent. I equivalent will be equal to I1 minus I2 dahil ito opposite in direction to this. No? Are there any questions with regard to sources in series, sources in parallel? So ang importante lang, when you have sources in series or sources in parallel, you have to recognize if the circuit is valid or is not valid, assuming that your sources are ideal sources. You have to recognize whether the source is valid or invalid. So just to test you, no, whether you understand valid or invalid, okay, do this through the chat box. Is letter A valid or invalid? Anyone? Somebody said invalid. Okay, I have 4 replies so far. And 3 invalids, 1 valid. Humabol na yung valid, 3 sunod-sunod na valid. Yan lang ba yung gising? So I have nananalo yung valid. May pumasok uling invalid. Okay. When is it invalid? It is invalid if it defies Kirchhoff's voltage law. So my test is I apply KVL to this particular loop. Okay. If I apply KVL to that particular loop, I'm going to get 10 volts. Okay. Minus 10 volts is equal to 0. Eh, totoo naman yan, di ba? 10 volts minus 10 volts is equal to 0. Therefore, just a minute, no? Sorry about that, no? Okay, so again, the test is if you apply Kirchhoff's voltage law here, if I get a consistent result, then it's okay, no? If I apply Kirchhoff's voltage law here, what do I get? I get 10 volts, kasi ito, you're going from negative to positive. So that's, let's say that's a voltage rise, so that's 10. Positive, negative voltage drop, that's 10, that's equal to 0. So this is correct. So this is valid. Okay. What about B? Valid or invalid? Okay, valid, no? Valid. Why? You apply KCL here. You apply KCL there, current entering is equal to the current leaving. The current entering is 5, the current leaving is 5, and therefore this is valid. Okay? Okay, what about C? Is that valid or invalid? So C. Anyone want to venture a guess? Thank you for attempting to guess. But this is valid. That's valid because there's no contradiction. No? let's call this I, and let's call this V. If I apply KVL here, all I'm going to get is V is equal to -10. No? That's applying KVL to this loop. If I apply KCL here, all I'm going to get is I is equal to 5. There's nothing wrong with this, and there's nothing wrong with that. In other words, these two do not contradict. No? There is no contradiction. So this is still a valid circuit. There is no contradiction. Now, obviously, this is invalid. Because if I apply KVL to this loop, I'm going to get 10 minus 5 is equal to 0, which is obviously impossible. So this is invalid. And if I apply KCL here, I'm going to get 5 is equal to 2, which is again impossible. So that's also invalid. Okay? So you have to be able to recognize when circuits are valid or invalid. Very important. This is when you have sources in combination, or sources in series or sources in parallel. Okay. Spend 1 minute. No, what is the answer for letter A? No, I'll give you 1 or 2 minutes to do it. No, I just have to step out just for a short while. Okay, what's the value of alpha? What's the value of alpha? Wala bang nakasagot? Minus 15, 15, minus 0.6. Si Juan Paulo Isaac is the closest, but it's still not correct. No? The answer is 0.6. Okay, si Cedric Justin Encarnacion, it's 0.6. Okay, why is it 0.6? Okay, first let me do KCL here. KCL. So what am I going to get? I'm going to get, okay, the current entering is equal to the current, well, the sum of the currents directed out of the node is equal to 0. So I'm going to 15 plus alpha v of x is equal to 0. No? They're both directed outward, so they are both positive. No? This is, sorry, this is going to the right, and this is going down. No? So they're both positive. 15 plus alpha vx is equal to 0. Meaning to say alpha is equal to negative 15 over vx. But what is vx? Vx is negative 25. No? If you take a look, the polarity of Vx is opposite the polarity of this voltage source. This voltage source is plus sa baba, negative sa taas. Yung Vx naman, plus sa taas, negative sa baba. Therefore, Vx is equal to negative 25. Therefore, alpha is minus 15 over minus 25, which is equal to 0.6. Okay, so alpha is equal to 0.6. For the calculated value of alpha, find the power associated with the 25-volt source. So ano yung power associated with this 25-volt source? Actually, kahit na hindi mo alam yung alpha, malalaman mo yung power dyan eh. Okay, anyone? What is the power associated with the 25-volt source? Hint. What is this current? What is this current? That current is just dictated by this current source. Right? So I is equal to 15 amperes. So what is the power associated with the 25-volt source? Okay. So the power is just V times I. No? So that's 375 watts. Now question, is it positive or is it negative? Okay, the answer is it is positive. Because according to the passive sign convention, okay, if this is your polarity of voltage and this is your direction of current, in this particular case, the power is positive. So this is consistent with the passive sign convention. We have a 25-volt source and you have a 15 ampere current. So this is consistent with the passive sign convention. Your current is entering the positive terminal. Therefore, your power is positive. So the question is the 25-volt source absorbing or delivering power? Yun, I'd like to hear some answers from you. Is it absorbing or delivering power? Yes, that's correct. No, it is absorbing power. In other words, it's counterintuitive. It's a source, but actually the source is not delivering power. The source is absorbing power. Okay? May pagka-counterintuitive. Usually a source delivers power, but in this particular case, this source is absorbing power. Which is possible naman eh. No? For example, a battery is a source, but if you're charging a battery, it's absorbing power. Okay? So any questions with regard to this? Okay, I have to hurry up. No, we're out of time. Sorry. Okay, let me discuss voltage division. We still have 2 topics to discuss. I hope to take up the next 5 to 10 minutes. No, so overtime tayo ng konti. The total voltage across a group of resistors in series distributes to the individual resistors proportional to resistor values. So yun yung operative term dyan. Proportional to resistor values. Let's say, let's try to, let me try to explain that intuitively. No? Let's say I have 2 resistors in series. Let's say this is R1, this is R2. So this is VR1 and this is VR2. They are in series. If R1 is equal to R2, then VR1 should be equal to VR2. Right? Why? Because if R1 and R2 are equal, then this voltage will distribute itself equally to R1 and R2. And therefore, VR1 should be equal to VR2. If R1 is equal to 2 times R2, then VR1 should also be equal to 2 times VR2. In other words, if this resistor is twice the value of this resistance, then this voltage will also be twice the value of this particular voltage. Now, if VR1 is twice VR2, then that means itong V, 1/3 pumupunta dito sa R2, 2/3 pumupunta dito sa R1. Ano? So, ibig sabihin yan, VR2 is 1/3 of V, and VR1 will be 2/3 of V. This is the only way we are going to get the 2:1 voltage ratio. If VR1 is 2/3 of V and VR2 is equal to 1/3 of V. Anyway, this formula says it all. The ith voltage is equal to V multiplied by the ith resistance over the sum of all resistances. So that is voltage division. So let's take an example. This is a photocell. Characteristic of a photocell is that it receives light, and depending on the intensity of the light, its resistance changes. The stronger the light, the smaller the resistance. So inversely proportional to the incident light. Kung malakas yung ilaw, maliit yung resistance. Okay, anong ibig sabihin nito? Ibig sabihin nito, this point is at 5 volts with respect to ground. So another way of drawing this is I have 5 volts here. I have a 5.6 here. And then here I have my photocell. And then this is V out. So this V out is also with respect to ground. Okay, notice that V out is just equal to 5 multiplied by R over the sum, no? R plus 5.6K. This is 5.6K. Right? So I have here various values of V sub out. Isa-substitute ko lang dito. And I should get the corresponding values of R here. So anong value ng R? Anong value nitong R pag bright? Anong value ng R kapag dim? And anong value ng R kapag dark? And these are the answers I'm going to get. So this is plugging it in, no? I'm going to get 1,004 ohms, 7,013 ohms, and 10,042 ohms. Okay, current division. So kung may voltage division, meron din current division. The total current across a group of resistors in parallel distributes to the individual resistors in proportion to conductance values. Dapat in proportion to conductance values. So I have this current. I have all these resistors in parallel. Okay. How will this current distribute itself to my different resistors? It will do it in proportion to conductance values. Okay. So if, for example, no, same thing as a voltage divider. Let's say I have two conductances. G1 and G2. So this is I1 and I2. Okay. If G1 were equal to G2, then I1 will be equal to I2. If the two conductances are equal, then the currents that will flow through each of them will also be equal. If G1, for example, were 2 times G2, then I1 will also be twice I2. I1 will be 2/3 of I, and I2 will be 1/3 of I. This is the only way, in 1/3 plus 2/3 is 1, that this is the only way I can get the 2:1 ratio. If 1/3 goes to G2 and 2/3 goes to G1. So again, this is how you translate it into a formula. Now note that G is equal to the reciprocal of R. Now you have a special case when you have two resistors in parallel. So ito, no? Ito, two resistances in parallel to, except that I specified it in terms of conductance. Excuse me. So I specified it in terms of conductance, no? But if you have two resistors in parallel, okay. So this is R1 to, no? And this is R2. So notice I1, itong I1, ang numerator niya would be R2. Yung kabilang resistor, no? Divided by the sum of the resistors. And then itong I2, ang numerator niya will be R1 divided by the sum of the resistors. So here's an example. An ammeter is an instrument that measures the current flowing through it. No? So this is an ammeter. What does this measure? This measures this current. No? This is IM. This is the current that A measures. Now the ammeter can be represented by a 50 ohm resistance. So equivalent circuit niya is 50 ohms. Right now, ang nasa sukat nitong ammeter is up to 1 mA. No? So this can measure up to 1 mA. Now what do? I put a resistor here, okay, so that itong I, part of it will flow this way, and then part of it will flow this way. And what I want to happen is I want this to be 90% of I, and I want this to be only 0.1% of I. So anong kagandahan nitong scheme na to, no? If this resistor always draws 90% of I, and this is always 10% of I, no, 10% of I, then ibig sabihin, I can determine what the value of this current is by just multiply this reading by 10. So kung dumadaan dito sa ammeter na to is, for example, 0.5 mA, no, then I know that this current is 5 mA. So effectively, I have increased the current that this can indicate. So the first question is, what should the value of RSH be? What should the value of RSH be? And it's very easy to do that using current division. Okay, IM will be equal to I multiplied by, okay, ano yung kabilang resistor? RSH all over RSH plus 50 ohms. And this is equal to 0.1 I. So itong I cancels out, and you can solve for RSH, and you're going to get the value of RSH is 5.56 ohms. And effectively now, the maximum current that A is capable of indicating will be 10 mA. So the answer is 5.56 ohms and 10 mA. So dati-dati, this could only measure up to 1 mA. Lalagyan ko nitong resistor na to, which you call a shunt resistor. It's 5.56 ohms, and now this can measure up to 10 mA. Because 90% of the current will always be bypassed through this shunt resistor. Okay, I'm going to leave this last example as an exercise for you to do. So this is a combination of, actually this problem already came out. This is actually the same problem that came out at the end of module 1. No? So may solution na to sa end ng module 1. But what I want to say is you can use, sa module 1, ang ginamit nyo was KVL, no, and KCL. But you can use voltage divider and current divider. No? So this is a transistor amplifier. Okay, here, to get V, you can use voltage divider. And then here, to get I, you can use current divider. You should be able to solve this problem in a different way as end of module 1. So that's my last slide. No? I'm sorry again for going over time. So quickly, are there any questions? Any questions with respect to what we took up today? None? If you have any questions, I'm just an email away. No, and then I'm going to try to post the recording of this lecture as soon as possible also. Okay, so that's all for this afternoon. Thanks a lot.
Thank you, sir.
You're welcome.